Hello and welcome to the lesson for today. We're going to be going over briefly. I know that you've already gotten some of this done, so I won't belabor a lot of points, but we've already gotten into probability and statistics. And what we're going to go to first is the part of probability and statistics. You can see it in the second slide down there. That is the tree diagram. And you see this tree diagram is basically a representation of the assignment you have to do. I saw that you'd already done most of it, but you hadn't completed this aspect of it. And what you have here is basically a representation of rolling a six-sided die once. Hence, the possible outcomes are 1, 2, 3, 4, 5, and 6. And what you're going to be working on is doing it with that second roll. We put in one example here. For instance, if you roll the die once, you can get 1 through 6. And if you roll it again, you can still get 1 through 6. So if you rolled a 4, you could get a 4 and a 1, or a 4 and a 2, or a 4 and a 3, or a 4 and a 4, or a 4 and a 5, or a 4 and a 6. So there's a grand total of 6 times 1, 2, 3, 4, 5, 6, 36 combinations that you can get. Okay, so the first question that you were asked was, what is the probability that you will roll 2 even numbers? Okay, so let's figure this out. In the case of rolling the even number 4, you can get a 4 and a 2, or a 4 and a 4, or a 4 and a 6, because you have the 2 there, the 4 there, and the 6 there. So with that one even number, you have 3 possibilities, and it would be the same up here. So this is that chart part you have to finish on that homework sheet on Google Docs. So you could get a 2 and a 2, a 2 and a 4, or a 2 and a 6. So you have 3 there and 3 here. And if you rolled a 6, which is the only even number left between 1 and 6, you'd also have 3 down there. So 3 plus 3 plus 3 is 9 out of a total possibility of 36. So going back to the problem, what is the probability you roll an even number? Well, 9 out of 36, but that is not in the simplest terms. 9 out of 36, well, 9 goes into 9 one time, 9 goes into 36 4 times. So you indeed have 1 out of 4 as your probability. And here's another type of probability question. How many different ways can a carpenter build a bookcase using one of each? 4, let me use the highlighter, 4 different types of wood, 3 stains, 5 widths, and 6 heights. Well, you basically turn this, as I'm sure you remember from learning it in the lessons, into a multiplication problem where you have 4 different types of woods times 3 different types of stains times 5 different widths times 6 different heights. So 4 times 3 times 5 times 6. 4 times 3 is 12. 12 times 5 is 60. 60 times 6 is 360 different ways. Different, C-O-M-B, abbreviation for combinations that you could get. So that's the finishing of those several problems. Let's move ourselves down here to the next questions that we have to deal with, which is the old bag of marbles. Yeah. Okay. So you have a bag contains 2 green marbles 9 brown marbles, 7 yellow marbles, and 4 blue marbles. So altogether, we're talking how many marbles do we have? Yes. 2 plus 9 is 11. 11 plus 7 is 18. 18 plus 4 is 22 marbles. But for this question, it says once a marble is selected, it is not replaced. Find each probability. The probability of pulling a brown and then a yellow. Well, what's the probability of pulling a brown? Well, there's 9 brown out of 22 possibilities. And then the probability of pulling a yellow is 7 yellows out of, well, how many are left? It's not 22 anymore because the marble is not replaced. Got to pay attention to directions. So it's 9 over 21. Now, before you go doing your multiplication, you can simplify this using the common factor between 9 and 21 of 3. So you say, how many times is 3 going to 9? 3. How many times is 3 going to 21? 7. So now you have 3 over 22 times 7 over 7. You say, wait a minute. 7 over 7, any number over itself is a whole number. And what's the simplest fractional form of a whole number to use? Well, yes, 1 over 1. Because 7 over 7 is indeed equal to 1 over 1. So now we have 3 over 22 times 1 over 1. 3 times 1 is 3. 22 over 1 is 22. So bingo, there's your answer. Oh, by the way, this is one of the answers in the worksheet you'll be doing. Okay, so now problem 7. So you can even see which problem it is. What is the probability of a brown and then a yellow? Which is, hold on. Oh, see, that's what's different. I did not put the other direction in here. This time, the marble is replaced. So what's the probability of a brown? Well, like it was the first time in the first question, 9 over 22 times, what's the probability of a yellow? 7 over, well, once again, we didn't take it out this time. We put it back in, the brown one, so there's still 22 possibilities. So 9 over 22 times 7 over 22. In this one, there's no cross-canceling, cross-reduction you can do. So you got to actually multiply it out. 9 times 7, 63, over 22 times 22, 484. So the probability of pulling out a brown and then a yellow when you do replace it is 63 out of 484. All right. Now we're using a combination of a 6-sided die, regular dice, and a spinner that is split into A, B, C, D. So what is the probability that you will roll a 4 on the die and a A? Well, what's the probability of getting a 4 when you roll the dice? 1 out of 6. Multiplied by, what's the probability of getting an A? Well, there's 4 different letters you can get, so it's 1 out of 4. So 1 times 1 is? Yes, 1. 6 times 4 is 24. So your probability of getting a 4 and an A is 1/24. Moving right along. Whoops, moved a little bit too far along. A bag contains 5 red M&Ms, 3 brown M&Ms, 6 yellow M&Ms, and 2 blue M&Ms. Once an M&M is selected, it is eaten. So what's the probability of getting a brown, then a yellow, then a red? Well, what's the probability of getting a brown? Well, first of all, you got to remember, how many total are there? 5 plus 3 is 8, 8 plus 6 is 14, 14 plus 2 is 16. So you start off with 16. What's the probability of getting a brown? Well, there's 3 brown out of 16. So now there's how many left? Yes, 15. And we're looking for a yellow, so you're talking 6. So far, remember there's 3 of them here, brown, yellow, and red. we have 3 over 16 times 6 over 15. Now the next time, how many M&Ms are left to pick from? Well, yeah, 14, because we ate the yellow M&M. And then the next probability is the red. And since we haven't taken any reds out yet, the probability would indeed be 5. So now you have 3 over 16 times 6 over 15 times 5 over 14. So if we do a little bit of that reduction before we do our multiplication, 3 will go into 3 1 times, and into 15 5 times. And 2 will go into 6. Three times, and into 14 7 times. And 5 will go into 5 1 times, and into 5 1 times. So we have 1 times 3 times 1, which equals 3. See? 1 times 3 times 1, which equals 3. And then we have 16 times 1, which of course is 16, and 16 times 7, which would equal 112. So your answer is 3 over 112. That's the probability of getting a brown, a yellow, and a red under these conditions. And the last thing we're talking about here is the old stem and leaf. It's always been one of my favorite. I do not know why. I guess I just like to look at data and split it apart. So you see the stems. These, in most instances, will be the tens, and the leaves would be the ones. So a stem of 2 and a leaf of 2 gives you the number 22. And a stem of 2 and a leaf of 6 gives you the number 26. And the stem of 2 and the leaf of 7 gives you the number 27. See, that's putting them back together. Now, in a second, I'm going to show you directions, and I say to when you have a set of data that you're going to make a stem and leaf plot out of, which you do in one of your assignments, it always has helped me to put them in order from least to greatest. You don't have to, but it goes a lot simpler, and you're a lot less likely to make mistakes if you do put them in order. Now you can also pause the recording and look at this brief little explanation, which kind of tells you a lot of what we talked about just now. Excuse me. You have stems of 1, 2, 3, and 4 here. So you'd split this 41 up to a stem of 4 and a leaf of 1. Okay. Not difficult to understand. So here's our last little example we're going to go over today. First, arrange your data points in order from least to greatest. Again, like I was just saying, it helps you not to forget any of your data points. What I'd like to do is I take my data points, I put them in order from least to greatest, and then when I'm going and making my stem and leaf things out of them, I cross them out as I go to make sure I don't forget one. Then you make your graph lines like this. You have your stem and your leaves labeled. Then you start placing your data points. So I look over here, and what actual stems do I have? A 2, another 2, a 4, and a 3. So I got to put them over here. A 2, a 3, and a 4. So again, they're in numerical order. So I have a 24, and I have a 22, and a 28. So I got a 24. Oh, I got two 28s, don't I? You got to make sure you don't make that mistake that I almost made. 28, 28, 22. Then I have a 32 and a 36, 32, 36, and a 37. And then I have a 43 and a 49. So now it's a whole lot easier. I already got my stem set, and I have to put a leaf of a 2 in, a leaf of a 4 in, and I have two 28s, so I have to put two 8 leaves in. So I'm sure that you could do the rest of this example on your own, but this just goes and shows you some of the things that will be helpful to you as you go about finishing up some of that math work. So give it a shot, send me an email if you have any questions, and we'll be talking in the future maybe. Goodbye.